and to UTD, and particularly to electrical and computer engineering. We've got great degree programs here and some great faculty who are looking forward to instructing you in the coming weeks and months. So I wanted to make sure that I tell you a little bit about myself. I've been department head now for ECE for about 5 years. And I've been at UTD for a substantial length of time. Not going to tell you how long that's been. So Dinesh has a wonderful orientation program for you here that should answer most questions. But I want you to know that as your future department head, I'm also very willing and able to discuss things with you and to help you along in your programs. So my own research, as Dinesh noted, is in plasma sciences. Plasmas are used in about 1/3 or so of the steps used to make all of the chips in your phones and computers, and actually in much of the technology that we use today. Without glow discharges, you couldn't make anything close to the devices that we use today. And I study about how it is that those discharges function. But actually plasmas get used in a much wider range of things as well. So even in things as far-reaching as medicine today, people use plasmas. I remember being quite enthusiastic when I saw an advertisement online for a negative ion toothbrush. So people were actually using plasmas, and I don't know what's become of it for today, but at that point in time, people were actually using plasmas to help people brush their teeth better, which is, I don't know, when you're in my business, it's quite an enjoyable thought. I'm not sure that I could understand what was just said. Was that a question, or can maybe type that into the chat so that I could understand? So we're in sort of crazy times right now. With the pandemic going around, this virus is a very serious threat. The US government has realized again that social distancing is important to our health, and has recently enabled our students again to be able to study in the way that's healthiest for the whole community. So that's some very good news. And we look forward to welcoming you both on campus and remotely. So with having said that, Dinesh, let me turn it back over to you.
Thank you, Professor Overzet. I will continue with our presentation. So today for the meeting, we are also joined by some of our distinguished faculty colleagues. Professor Poras Balsara is online. He is faculty in electrical and computer engineering. Professor Balsara also shares the research lab with me. It's the IDEA Laboratory. And also, he is the Associate Dean for Academic Affairs for the Johnson School. Then we are also joined by Professor Benjamin Schaefer. He is going to talk about computer engineering and computing systems research that happens in this department. Our department is a very, very diverse department where the research goes all the way from below the device level all the way up to some of the largest system level. So Benjamin Schaefer is very, very active in computer engineering areas. Professor Mehrdad Noorani, he is also online and he's going to talk about circuits. It is one of our largest concentrations. We get most students in circuits area and he's going to talk about opportunities in circuits. Then we are also joined by Professor Nasser Keter Nawaz. He belongs to the signals and systems area. In terms of the faculty strength, this is our largest area, and we also produce many PhD students in this area. So he's going to talk about signals and systems. And finally, from the concentration point of view, Professor J.B. Lee, he works in the MEMS area in the devices, and he is going to discuss the research courses and the opportunities for those who would like to study the concentration, which is the devices concentration. I thought it was appropriate for you to see how things are headed in the department, the directions we are taking in terms of some of the very important and future areas. So Professor Kanad Basu, he's one of our newest faculty members. He did his PhD from University of Florida, Gainesville, and then after some experience at NYU, he has joined here and he will talk about his research in hardware security. And then finally, I think every one of you probably is more interested in finding out what student experience is or what the student life is. And I have asked Satvik Datta. He is one of our PhD students. In fact, he has a very interesting background. He came in to just do a master's, and then suddenly he got very interested out of a course, and then he kept becoming more interested, and now he's a very active PhD student in the department. The ECE advisors, Professor Randall Lehman, Matthew Hines, Professor Marco Taka, and Professor Diana Kogan are also online, and you will be interacting with them before you will register for your courses. I will quickly start with some fast facts about Johnson School. We are a very young university as well as a very young engineering school. It started in 1986 with electrical engineering and computer science departments. And over the time, we have added a few more departments: the material science engineering, mechanical engineering, biomedical engineering, and systems engineering. Currently, we have about 8,500 students in the department. You will see the large number of students are at the undergraduate level, but we also boast a very strong and very large PhD program with about 600 plus students in the PhD program. The number of tenure track faculty members in our school is 151, and we have a substantial research expenditure of $57 million. We have one of the largest internship programs in the state of Texas, and over about 1,100 plus student placements in a year in the Dallas-Fort Worth area. So very active program, and I will briefly talk about that. We are spread across the campus in 6 different buildings. Well, we started out in 1987 in a building which now is the multipurpose administration building, but the electrical and computer engineering department is located in the ECS North, and then we added ECS South, which primarily hosts most of the computer science department. Then the Natural Science and Engineering Research Laboratory that was constructed in 2007. That is where most of our devices and some of the advanced materials related research happens. The Bioengineering Department is one of our newer buildings, and that was added in 2016. And finally, we opened just about 2 years ago, ECS West, which also houses the Mechanical Engineering Department. All of these buildings are very loaded with facilities, lots of equipment, lots of very advanced stage facilities, and they are state-of-the-art buildings. The Johnson School, this is a quick overview of the degrees that we offer. We have BS, MS, PhD in bioengineering, computer science, electrical and computer engineering, mechanical engineering, material science, and systems engineering. So it gives a student coming into any of these departments a diverse opportunity to also go and work with faculty in other departments. We are very, very interdisciplinary when it comes to the research and education. The ECE department, this is what I call as the foundation department of the Johnson School. The school was formed based on the electrical engineering department. Our mission is that our graduates are uniquely qualified for rewarding and successful careers in diverse range of ECE fields. We have concentrations that reflect signal processing, communications, circuits, digital systems, material devices, speech and image processing systems, a very big group in control systems, power, electronics, and energy systems, motor drives, biomedical applications of electrical and computer engineering. Just the department, it's a very large department, and the total enrollment, the most recent enrollment, is about 1,700 students in the department. We have three different programs: electrical engineering, computer engineering, and telecommunications engineering. TE is relatively smaller program, and it exists only at the MS and PhD level, but you will see that the EE and CE are substantial size programs. We are the largest PhD producing department in the entire university. Currently, we have 245 PhD students in the department, and we end up producing close to about 38 to 40 PhD students or PhD graduates every year. In the graduate engineering school rankings, as reported by US News and World Report, the latest one is 2020. The Johnson School has an overall ranking of 62. Among the public universities, we are ranked number 38. And then within Texas, after Texas Austin and Texas A&M, we are ranked as the third best public university in the state of Texas. Computer engineering is ranked 52 and 32 respectively, and then electrical engineering is ranked 50th and 28th among the public universities. And we are continuously rising, and I can quickly mention to you, if I go back and look at last 10 years, electrical engineering was somewhere in the window of about high 70s. Our growth has been quite fast. There is no shortcut, but I am very, very confident with the kind of students we have, the kind of research we have, the quality of faculty that we have. We will be going much higher in ranking in near future. We have total of 63 faculty members, 31 full professors, 3 associate, 6 assistant, then we have 12 senior lecturers and 7 lecturers. Very, very distinguished set of faculty. When it comes to looking at the recognition of faculty, we are electrical and computer engineering. One of the societies where we all belong is IEEE, the Institute of Electrical and Electronics Engineers, and 16 of our faculty members are fellows. One faculty member is ASA Fellow, ISCA Fellow, SP Fellow, Optical Society Fellow, and substantial research expenditure. So you will notice that out of 51 million that Johnson School gets, we are at about $13.5 million in last year. In terms of the department administration, you already heard from Professor Lawrence Overzet. He is the department head responsible for overall functioning of the department. My name, as I said earlier, is Dinesh Bhatia. I handle graduate studies. Professor Naufal Aldair, he is the associate department head for undergraduate studies. And finally, in one of the more important roles is Dr. Arya Nosratinia, who is responsible for scheduling of all the classes and courses that are offered every single semester. and someone that you will be also interacting with. The Johnson School Administration, so we have a dean that arrived last year, Dr. Stephanie Adams. She is also president of American Society of Engineering Education. So that is the body of engineering education, and this year she leads that group. Dr. Adams, she is the dean of Johnson School. As I said earlier, Dr. Balsara, who is also on the call today, he is Associate Dean for Academic Affairs for the Johnson School. And then Dr. John Hanson, he is the Associate Dean for Research in the Johnson School. And clearly there are more people, but what I'm doing is I'm listing the more relevant people who you will be most likely interacting with. And then when we go one level up at the university level, the university is led by Dr. Richard Benson. He is the president of UT Dallas. The chief academic officer for the university is Dr. Inga Musselman. She is the provost and executive vice president of the university. And the graduate studies, the entire graduate study portfolio for the university is headed by Dr. Juan Gonzalez. He is Dean of Graduate Studies. And I noticed in today's call, a large number of students are joining from various international destinations. And occasionally you will definitely need help in terms of your immigration status and other visa related issues. So I'm also including Josephine Vita. She is the Director of International Student Services Offices at UT Dallas. Inside the department, again, besides myself, the registration, degree plan, and audit for all the students whose last name starts from letter N through Z is handled by Miss Kimberly High. And I noticed that she is also on call today. Her contact information is also listed here. Then for all the students whose last name starts from letter A through M, those are handled by Miss Patricia Williams. She is also on call. And almost every one of you, when you applied to UTD, your application went through Miss Barbara Parker, and she is also on call today, and her contact information is also listed here. I want you to notice that if you are a teaching assistant or a research assistant, then all the documentation, timesheets, and other support is handled by three people in the department: Mary Rogers, Miss Joy Camp, and Miss Sherry Jones. And they are the ones who will be working with you with respect to your TA and employment related issues. Within the department, we offer various degrees. We have a bachelor's in electrical and computer engineering. We have a master's in electrical engineering, computer engineering, and telecommunications engineering. And finally, we also have PhD in electrical, computer, and telecommunications engineering. You also have a very unique opportunity of obtaining a MSEE plus an MBA. We have collaboration with the Jindal School of Management, and by doing right set of courses, you can actually pick MSEE and MBA in a relatively short window of time. So we have 5 different areas of study within electrical engineering. And starting with circuits, this is one of our largest offerings in terms of the number of students. Our students normally take courses in all of these areas. And then circuits is where we have emphasis on VLSI design, analog circuit design, and the RF circuit design. I strongly believe that in today's day and world, a circuit designer has to know the digital, the analog, and the RF component of the design. And we have a very, very strong program. And Professor Noorani will talk about that. Then we have computing systems, which is somewhat close to what computer engineering is also offering. And we will talk about that. Dr. Ben Schaefer will be talking about these areas. Devices is an area where Dr. Larry Overzet is there. Professor J.B. Lee is going to talk about devices, and power electronics and energy systems will be addressed to you by Professor Porus Balsara. Finally, signal systems will be Dr. Nasser Khetarnavas. So with that, what I will do is I will request Professor Noorani to come online, and he will describe the area of circuits.
Good morning, everyone. Dinesh, can you hear me?
Yes, I hear you and I see you. Thank you.
Thank you. Well, I also welcome everyone to this webinar and meeting. And like others, I wish that this era of pandemic gets over soon and you would be on campus. But for now, this is the way to communicate. I have been here for almost 20 years now, and I teach courses in digital area and VLSI testing, among other things. And my research focuses on circuit reliability, system and circuit testing, as well as biomedical devices and application-specific applications. So as Dr. Bhatia pointed out, the circuit is the largest group. And I do not intend to overload you with all sorts of information, but I just wanted you to be aware that what are the opportunities. You know, through your bachelor degree, most likely you have acquired certain skills and you develop certain interests in the areas. So I'd like you to pay attention to those few words that I underlined. So the circuit concentration is all about design and analysis. But the level of design and analysis might be different. In our department, the courses that are offered, you have varieties of courses that address at the device level, at the circuit level, as well as system level. These are, of course, slightly different, and the challenges and the optimizations that are involved are going to be different. Aside from the level of abstraction, you have opportunity to learn more in digital area, analog area, and radio frequency circuit area. Now we realize that these areas are also overlapping. So it's not like, you know, all of them completely separate. On the other hand, because the master degree is all about taking around 11 courses, so you have almost 2 years and a half to accomplish this. So 3 courses are core courses in that area. All of these are at the graduate level. So you might have seen some flavor of these topics at the undergrad level, but you will learn much more in the graduate level. One is VLSI design, second one is analog integrated circuits, and the third one is RF and microwave circuits. So why do we call them core courses? Because we want to make sure that once you graduate, all graduates, you know, in circuit concentrations would have high level of skills in these 3 key and fundamental areas. Now, beyond these 3 courses, you would have opportunity to choose 8 courses from a slightly diverse area. If you develop interest and passion for digital, you can take more of digital side. If you develop some interest in RF, you can take more courses in that area, or if you choose, you can mix these. So at least 20 plus courses are elective as you know, possibilities that you can take. I don't want to kind of go through them, but my advice is that as you take courses, pay attention what you like, what you want to be identified after graduation, and then you can proceed. So now, research possibilities. We love our masters and graduate students in general to do research. Now, of course, PhD program is all about research. They take some courses, but we love you to pay attention to the research opportunities. Research is something that you got to develop relationship with the professors. Once you take some of the courses, once you have opportunity to talk with them individually and show your passion, your background, and if the opportunity is there, and there are plenty of opportunities, at least 17 faculty work in circuit area, and if you visit our website, the ECE website, you can see faculties who are involved in different concentrations by choosing that concentration. So you can clearly see the opportunity there. Now, I would like to finish 1 more minute, Dinesh. Sorry if it took longer. Historically, our graduates joined 3 group of industry. One is are those companies that have fabs, like Texas Instruments, Intel, Global Foundries, and IBM. The second group are those that work mostly on ASIC, application-specific integrated circuits. I listed them on the second row, like Apple, Samsung, Analog Devices, Cisco, and so on. And the third one are EDA companies, those companies that develop CAD tools for simulation and synthesis, such as Cadence, Mentor Graphic, and ANSYS. So once again, welcome to UTD and welcome to ECE, and we look forward to interacting with you more. Please feel free to send me email in case that you have any question about circuits or other things if I know to answer that. Thank you.
Thank you so much, Dr. Noorani. And I want to move forward with the next concentration. Dr. J.B. Lee. He works in the MEMS area, and he will talk a little bit more about the devices area, the courses that are available, the opportunities that are available, the research that happens, and where students go. Dr. J.B. Lee.
Well, welcome to UTD ECE department for this challenging time. My name is J.B. Lee. Let me talk briefly about the core courses in the devices area. So we have the 3 core courses, 6316 fields and waves, and 6319 quantum physical electronics, and 6311 photonics devices and integration. So anybody who wants the devices as your concentration, you must take these 3 courses. And then you have a lot of freedom for taking other courses. Of course, you need to talk to your advisors. If you have academic advisor, then you must talk with your advisor to what kind of courses that you must take in your field of study. So let me briefly talk about the faculty's research areas. Once again, there are it seems like the less number of faculties than other concentrations, but devices area is very, very active, and we have a very distinguished faculty. So Dr. Walter, who is mainly working on nanoelectronic biosensors and nano-imprinted organic solar cells, so he's really the nano scientist, nano engineer. Dr. Gil Lee is specialized in carbon nanotube sheets, yarns, and the CNT-based the transparent electrodes for batteries, and he also works on CNT-based sensors. Myself, J.B. Lee, I am working on MEMS, and I have been working on biomedical devices using MEMS technologies. And recently, I am working on liquid metal microfluidics. Dr. Shabas Purkamali is also, his expertise lies in MEMS, and he's expert in high-frequency resonators and resonator-based sensors, and a lot of interesting thing going on in Dr. Purkamali's lab. Dr. Chingu is one of the new faculty members in the devices area. So her expertise in nanophotonics and on-chip lasers and photonic integrated circuits and things like that. Dr. Lawrence Oberzet, our department head, his research area is plasma science and applications. So some of the areas that he has been working on is deep silicon etch, the fundamental understanding of the deep silicon etch, and micromisted plasma and microplasmas and those kind of areas. Dr. Bill Fransley is one of the experts in the semiconductor device modeling and quantum effects in semiconductors. And even though it is not listed here in this slide, we have the Dr. Matthew Hines. I believe he is also joined in this orientation. He is a senior lecturer. He has been working at Corvo for a long time, and he is a device expert. Dr. Iyer, he joined from TI, so he was the vice president in Texas Instruments, and his area of expertise is packaging, device packaging. So he adds a lot of the research into device area. Although the home department is not in ECE, Dr. Chadwin Young in material science and engineering is also partly involved in ECE, and his area of expertise is also semiconductor devices and measurement. Job prospects, I can just tell you that some of our graduates, where they are placed, Texas Instruments and Corvo and Raytheon, they are all located in North Texas, and they are one of the those companies that a lot of us graduates got jobs from. Lam Research and Samsung, Micron, and Intel and Global Foundries. As you can see, lots of the semiconductor manufacturing companies or semiconductor equipment manufacturing companies hire our graduates. And also, Apple and IBM, they also invest the devices area. So some of our former graduates are placed there. So that is the overall, the very brief overview about the devices area.
Thank you so much, Dr. Lee. We will move on to the next area. Professor Poras Balsara, he is also online. Go ahead, Dr. Balsara, please.
Good morning, good afternoon, good evening, depending upon wherever you are listening to us from. And welcome to UT Dallas, and welcome to the Electrical and Computer Engineering Department. Dr. Nurani and Dr. J.B. Lee, they have made my life slightly easier right now, because a lot of things that they have said in terms of doing research, collaborating with faculty members and all applies to virtually all the areas in our department. I work in circuits and systems area, digital area, as well as power electronics and energy systems related areas, mainly on the aspects of digital control and digitization of different systems. So today I'm going to put on the hat for power electronics and energy systems. So in this area, we have several faculty members. It's one of the newest areas that we started over the last 8 to 10 years. And it is rapidly growing in terms of student enrollment as well as faculty research interest. So in this area at the master's level, you have 3 core courses. These are fundamental courses in power electronics and energy systems area. So we not only focus on just plain power electronics, but also on motors and drives and power systems related aspects, mainly modern power systems. So the 3 areas are fundamentals of power electronics. So this is a graduate level course. So you might have already done. Dinesh, can you go back to the previous slide? Yeah. This is a fundamental course, which you must have done an undergraduate level course in power electronics, but this goes into more advanced aspects of power electronics. It's a graduate level course. Then there is a general theory of electric machines. So it's mainly focused on fundamentals of electromechanical energy conversion. And then the last topic in the core courses is control modeling and simulation of power electronics, because this whole area is rapidly evolving. So a lot of aspects of power electronics are studied and modeled at the software level before expensive systems and devices are built. And beyond this, you choose several courses from a bunch of electives. We have electives from other areas in electrical engineering and across the school in other departments that you might want to choose from, depending upon what is relevant to your research. And then you can either do a thesis option or do some independent studies if you're interested in exploring this area independently, if some courses are not being offered and you are interested in working in that area with a faculty member. Next slide, please, Dinesh. Dinesh, next, yeah. So in terms of research in power electronics and energy systems, we span all the way from chip level power electronics all the way to large systems. So in general, these are the 4 areas, and most of our work that we do span in these 4 areas. So transportation, electrification, in that we are looking at different aspects of electrification in transportation. So there are faculty members involved in EV type systems. We don't build EVs or electric vehicles here, but we do work on motors and drives and other systems related to EVs. There are people exploring electrification of airplanes, so air transportations and so on. So when you talk about the motors that go into transportation, you have to talk about fault tolerant drives, reliability, and other aspects. So there are all sorts of things going on. So I've given you a couple of samples here. One is the is a switch reluctance motor, double stator switch reluctance motor that was invented here by Dr. Fahimi. And then there are other aspects of power electronics that are kind of integrated with motors. And so this is the new area that is rapidly evolving. It's integrated motors and drives. So basically you take off the shelf, say induction motor, and put the power electronics and control to make that motor run efficiently, and everything is kind of integrated in one housing. The next area is distributed power generation control. So this involves the areas related to smart grid, microgrid, nanogrids, integration of inverters in grid. How do you do energy management? How do you do bidirectional transfer of electric energy from different renewable sources and so on? The next area is energy management, storage, and harvesting. So in this, we are looking at system level energy storage, energy harvesting. So basically scavenging hydrogen from different places for fuel cells, or doing an on-chip energy scavenging devices and so on. Also looking at remote charging of biomedical devices using, say, capacitive coupling or inductive coupling, depending upon the applications. And then the last and the biggest area is general power electronics, motors and drives. So people are exploring different machine technologies, different ways of optimizing machine designs. And now the focus is on not just looking at machines and power electronics separately, but combining the two together to come up with a most overall optimized system. People are also looking at wide bandgap devices and their applications for high frequency power converters or high voltage power converters. So we have faculty members who work in power electronics that work at low levels of voltages, like 1 volt or below at the chip level, all the way to medium voltage devices where we are looking at systems involving 13 kilovolts and above kind of stuff. So this kind of gives you a good flavor of what this group does in terms of research and teaching. In terms of job prospects, most of the companies that were mentioned earlier do hire a lot of people in power electronics and converters, and to that you can add other big companies like ABB, Hitachi Research, then Lennox for air conditioners and other, and all the EV based companies and so on. So this kind of gives you a good overview of this area. So I'll be more than happy to answer any questions later on, or you can shoot me an email. So thank you very much. And once again, welcome to UT Dallas. Welcome to Electrical and Computer Engineering. And I hope you all stay safe and we get to see you very soon. Thank you.
Thank you, Dr. Balsara. We will continue. I do want to add last, because when Dr. Balsara mentioned about opportunities, lately I have seen quite a few students, at least some that I've talked to, who have gone to Tesla. So that is starting to become a prominent internship option for our students. The next area for us is the signals and systems. Before we move on, I do hear some echo and noise that is coming in. If you are online, would you please make sure that your mic is muted? And now we will start with signal systems. Dr. Nasser Keter Nawaz, he will talk about this area.
Thank you, Professor Bhatia. Hello, everyone. My name is Nasser Keter Nawaz. I work in the area of signal processing, machine learning, and I'm going to give a brief overview of the signals and system concentration area. Similar to, if you are a master student, similar to other concentration areas, you need to take three required core courses. In the signals and system concentration area, one of the three required core courses must be EESC 6349, probability, random variables, and statistics. The other two required core courses must be from this list of three. Linear systems, digital communication systems, and digital signal processing 1. Can you take all four courses? Of course you can. Three of those courses are going to be counted towards your core courses, and one will be counted towards your 33-hour of master degree. Next slide, please. There are 14 faculty members in this area teaching courses and also conducting research in the signals and system concentration area, both in terms of courses and in terms of research. There are two main activity thrusts in this concentration. Communications thrust, including wireless communication, communication networks, and information theory, signal processing thrust, including speech processing, image processing, machine learning. Yes. Next slide, please. Yeah, here is a list of the center and research labs in the signals and system concentration area. This is not a full listing. I highly recommend that you visit the departmental research page and also faculty personal web pages for details, what kind of research activities are being conducted at the center and also in these research labs. So please refer to the departmental research page and also faculty web pages to learn more about research activities in the labs that are listed here. In terms of courses, 20 plus courses are offered in the signals and system concentration area. Again, I encourage you to visit this link, this website that has a description of all the courses that are offered in the signals and system concentration. Of course, not all 20 courses are offered each year. Some courses are offered once every 2 years. Now, as far as this coming fall 2020 semester is concerned, you can look at the list of courses offered by going to this website, coursebook.utdallas.edu. There are 7 courses in the signals and system areas that are offered this coming fall 2020. 3 out of 7 of these courses are core courses of the concentration. So the core courses in fall 2020 that are offered are probability 6349, 6331 linear systems, and 6360 DSP1. Other courses in the area that are offered in fall 2020 are information theory, digital image processing, speech and speaker recognition, and a special topic course on optimization theory and practice. So these are the And all of these courses do not have any prerequisite classes, any graduate prerequisite classes. So if you are, you can take any of these courses, assuming that you have the right kind of undergraduate, you've taken the right kind of undergraduate courses. At the end of the talk, I'll be glad to answer any questions you may have about these courses that are going to be offered in fall 2020. Thank you, Dinesh.
Thank you, Dr. Ketan Nawaz. Then the last area, which is the concentration in the electrical engineering stream, is the computing systems. And what I decided is that I will try to merge this discussion along with our computer engineering program that will be presented by Dr. Ben Schaeffer. So computing systems is a concentration where, again, just like all other concentrations, you have 3 core courses: the digital logic, advanced digital logic, computer architecture, microprocessor systems, and then you have a whole list of close to about 15 to 20 elective courses, which will give you the flavor of advanced computing systems. This has some degree of similarity between what we do in computer engineering. The faculty that we have in the department do crossover. These are not dedicated faculty members who are in the computing systems. They also work in computer engineering. So with that, I will bring in Dr. Benjamin Schaeffer. He is going to talk about our computer engineering track, where we actually, this year, we are introducing a new, very exciting concentration, which is called as the embedded systems track. And Dr. Ben Schaeffer will give you all the details of computer engineering. Ben, please go ahead.
Thank you, Dinesh. Thank you, Dinesh. Can you all hear me?
Yes, go ahead.
I'm assuming that you can hear me. So it gives me great pleasure to introduce a computer engineering program, which is one of the fastest growing programs within the ECE department. We have 2 tracks, as Professor Bhatia mentioned. The first one is the traditional track. This is the embedded system tracks. And in this track, you have to take these 4 core subjects. And if you look at the prefix of the courses, 2 of them are ECE courses that our faculty members offer. There's computer architecture and VLSI design. And the CS courses are basically offered by the CS people. So computer engineering as a mixture between hardware and software design. That's why you have to learn courses that cover the hardware, but also the software. The interesting thing about computer engineering is that it's evolving rapidly. So we cover everything that deals with computers, and computers are changing now. Your smartphones are a computer right now. So traditionally in computer engineering, you will learn about hardware, software, and the intersection between the hardware and the software. And that's basically what we're trying to cover in this first concentration, the embedded systems track. But we recently created a second concentration, the computer system tracks, for those of you who are more interested in focusing on the hardware side of computer engineering. And you see here the 4 core subjects: computer architecture, microprocessors, reconfigurable computing, and applied digital signal processing. So these are the core subjects. These are subjects that you have to take in order to graduate from our master degree program in computer engineering. These are core subjects because they're important. Without those subjects, you will not, if you don't master the contents of those subjects, you won't be able to understand the other electives that follow on. And also, it's important that you understand all the concepts in these core subjects, because there are often, these are the questions that you will get when you go for when you get to a job interview. They will ask you in computer architecture, what is a cache? What is the difference between a RISC or a CISC processor, and so on. So these, you really need to master the concepts in these core subjects to get a job afterwards. So that's why we put a lot of emphasis in these core subjects. Next slide, Dinesh.
I want to make a quick note before we go to the next slide. I do notice there is a minor typo here. The courses that you see are listed correctly, but the track areas are flipped. So the first one is actually computer systems track, and the second one is the embedded systems track, and I greatly apologize for that.
Okay. Thank you, Dinesh. In terms of research work that the faculty members in CE do, I listed some of the main areas. And again, they cover everything to build a computer system, from the tools to build the computer systems. And when I mean the computer system is the integrated circuits that go into the computer system. And this covers basically, it's the areas called electronic design automation, to computer architecture, to hardware security, and to tolerance testing and post-silicon debug. And we are all mentioning and going through these research areas because some of you might be interested in a specific area, and you might want to contact one of the professors working in that area to do a master dissertation, make a thesis, put in more emphasis in your degree in that specific area. For example, in design automation, most of the work being done these days to create integrated circuits, you have to write low-level hardware description languages. Most of you might have learned Verilog VHDL. So we're doing a lot of research in raising the level of abstraction to write with C code and then synthesize it into Verilog VHDL. So not having to write those low-level, using those low-level hardware description languages. In computer architecture, we have seen in the latest chips that these are heterogeneous SoC, systems on chip. They don't just have multiple cores, multiple processors. They have processors combined with some sort of hardware accelerators, like in your smartphones, in your Apple phone, you have this Face ID. Apple introduced this neural engine, this neural network within the chip. This means it's a heterogeneous chip. It doesn't have the same component replicated multiple times. So we have many colleagues working on how to build these heterogeneous SoCs. This is at the chip level. At the computer level, we have computers with FPGAs. So we have lots of courses in terms of reconfigurable computing, FPGAs, how to program this. And some of the colleagues work at the data center levels. Now everything goes to the data, to the cloud. So in the cloud, you have computers that have the traditional CPUs, but then they also have GPUs and also FPGAs. So how to design these complex systems, heterogeneous systems, from the chip level all the way to the data center. Many other colleagues work on hardware security. It's a big topic, especially in the US. And considering we have so many companies that work in VLSI design, because most of the companies are what's called fabless these days. They don't have their own facility to manufacture these ICs. So they do the design in the US, like Apple, for example, or Qualcomm, but then they have to send their chip to some fab outside of the US. And who guarantees that these people from these fabs will not over-design or will change your design or will steal the design? So hardware security is a very hot topic these days because companies put a lot of effort and money into building these products, and they don't want other people to copy their design. So how to prevent these other companies copying the designs, or even how do you detect if a chip has been recycled or not recycled? And the last area that I wanted to highlight is post-silicon debug, fault tolerance, and testing. With designing in computer system, much of the work is obviously the design. That's what you see. But there are more engineers required now to test the chip, the computer, when it comes back, to test it, to make sure it works, than to actually design it. So it's what we've seen at UTD is that many of your colleagues or the students get jobs in testing and post-silicon debug and so on. So we have hired a new colleague, Professor Kanat Basu, will talk later on. He did one of his first students working on this post-silicon debug area. And it's important, we wanted to put more emphasis in this area because we're seeing many of you guys, when you get jobs, companies like Intel, AMD, or Apple, is that you will end up doing testing, post-silicon debug, and so on. So this is a big important area for us as well. So these are some of the research areas that some of us work on. Again, the main idea of highlighting these areas is in case that you want to do a master dissertation and focus in one of these research, in one of these areas. So thank you, Dinesh.
So our last presentation is by Dr. Marco Taka. He represents telecommunications engineering. This is a separate program where we have an MS and PhD. Dr. Taka, please go ahead.
Thank you, Dr. Latia. Right, so the telecom, good morning, everybody, good afternoon, good evening, and depending on where you are in the world. The telecom engineering program is a highly interdisciplinary program that requires a blend from electrical or computer science, electrical engineering or computer science, and anything in between. And as far as the master is involved, like all the other masters, it requires 30 credit hours of credit, which translates to 11, in most cases, it translates to 11 classes. And the organization of the classes that for the master, you have 5 core classes which are listed there. And again, from the classes there, you can see proof of what I was saying, that highly interdisciplinary. So you see there 2 EE classes, which are random probability and random variables, digital communication system, and then some more high-level CS classes, such as algorithmic aspects of telecom networks, performance of computer system, advanced communication in computer networks. Then past those classes, you have a choice of an additional 18 credit hours that you can have a little bit of freedom to decide where to focus your your interest. So, for example, as I was saying, telecom engineering is a very wide program that covers a lot of areas that go from very low level radio frequency, characterizing links between devices, to designing modulation schemes, keeping synchronization between devices by sharing clocks, to designing transmitter and receivers, antennas, to designing switches and routers, protocols that go on top of that allow you to be on this call today, to design and systems that can be managed using network virtualization. You might have heard about software-defined networks, one of the hot keywords nowadays, all the way to cloud computing, how to make sure that you have this huge room filled with process device that can process information. How do you take advantage of that? A lot of problems today have become so big that no matter how powerful one single computer is, you cannot do it with one single computer. You need to take advantage of parallel communication. And once you start creating parallel communication, one big issue is how you create efficient communication between computers. And that's, for example, why big companies like Google, Microsoft, as well as Amazon, normally they were on the computing side of the data center. In the past few years, they heavily switched on the communication. They design, for example, Google designs their own optical switches to communicate, to create effective communication in their data center. So it's a very wide area. You will have a lot of opportunities to choose to first concentrate on your core courses to build a fairly wide background, and then concentrate on where your major interest in the telecommunication area is. As far as research, at UTD, there is a wide range of research in the telecom area that go from fairly low level. So, for example, that might be in a way kind of overlapping with the computer engineering. So, for example, there are researchers at UTD that try to characterize the impact of different computer architectures, or the impact of systems like 5G networks and beyond on different architectures. So combining Intel Skylake processors with Comet Lake processor and see how much they handle and how much they are loaded by implementing 5G using those devices, to building and testing prototypes of networks based on commercial hardware. For example, that's mostly the area where I work with. I work with the other professors at UTD, but for example, we have live high-speed optical network in the lab, as well as a relatively simple 5G system that we can use for experiments, all the way to higher level, such as defining new protocols and how they work, security of networks, how to make sure that networks are secure and your data is not easily accessed by hackers, to network management, network design, how to design networks efficiently. It's a very challenging problem when you start and design your network. And on top of that, most of the time, you don't design your network from scratch. You already have an existing infrastructure that you don't want to throw away, so you want to gracefully evolve to get the latest technology without throwing away everything that you have spent money. So, long story short, very wide range of classes that you can choose from to better satisfy your interests and go in the direction that you are mostly interested. Very wide range as well as job opportunities after graduation. As I mentioned, companies that were not typically in the telecommunication business, due to how things are evolving with virtualization, cloud computing, and all of these things, are heavily relying on telecommunication engineering graduates to keep up with their networking infrastructure. And I mentioned the big guys such as Amazon, Google, and Microsoft, but many other companies are realizing that they cannot just buy a network. It's very important to have control of their network. So I think that's all. So I can pass the token back to Dr. Batia, and again, if there are questions, I'll be available after the presentation to answer.
Thank you, Dr. Taka.
Thank you.
We will move on for our presentation. I think after this slide, we have very, very few slides which are with regard to the graduate program rules, as well as details on how you will do the registration. But I quickly wanted to mention that we also have a combined MSEE and MBA program. Generally, what will happen is you can obtain an MSEE degree with 33 semester credit hours, and the MBA degree that requires 53 credit hours. So if you were to add those, it comes out to be close to about 86 hours. But you can do a joint program where you take only 24 semester credit hours in our department and 44 semester credit hours in the business school. So for 68 hours, you can obtain both MSEE and MBA degree. And if you're interested in that, please feel free to reach out and I'll be happy to answer those questions. And then you heard about all the areas. This is something that I will want to quickly talk to you about. We do have an option where you can do an MS with a thesis. Thesis is a very unique opportunity that gives you an opportunity to look at a problem, try to get into the depth of the problem, solve the problem, and then document and publicly defend that. That's a very unique experience for an MS student, and I will highly encourage students to consider going with an MS with the thesis option. And that also sometimes creates a path towards a possible doctoral degree. So before we now move forward, we just have very, very few slides that are remaining here. What I want to do is something. I will stop sharing the screen for the moment. And just for next maybe couple of minutes, my request is all of you who are coming in from various destinations, worldwide destinations, if you will please turn your videos on, and I will take some snapshots before we move on to the next part of our presentation. So on a count of 1, 2, and 3, please bring your video cams on. Go ahead. 1, 2, and 3. Oh, so many wonderful faces are starting to show up.
I love this idea, Dinesh.
And just for your information, the entire presentation is being recorded, so we will post the video of this. You should be able to see. Here is what I am doing is I'm quickly taking some screenshots, and it's really wonderful to see all of your beautiful faces. And I hope to see you in the classes in very, very near future. So we have.
Say hi.
Hello to everyone, and okay, we will go back to our presentation, and I am back to the screen that we were at. It is important that you know your degree requirements. Just give me a moment. So the catalog for the graduate school, it is listed. It is required that when you are in our degree programs as a graduate student, and this should be definitely noted by some of the students who obtained undergraduate degrees, both from UTD and within some of the US schools, that the overall minimum GPA requirement to maintain good standing is 3.0. You should maintain a grade point average of 3.0 out of a scale of 4.0 in your core courses, as well as the overall GPA. The ECS department will conduct audits for your degree plans. Degree plan is a tool that helps you track your progress, and that is where you will fill out what core courses, what concentration areas that you're interested in that you will take. And in addition, you will also, with advice from your advisors, academic advisors, you will select the elective courses also. So I want you to make sure that you choose your classes so that you maximize your learning. And I know sometimes what happens is friends tell you that, okay, go for this class, that's a easier class or harder class, but please do make sure that you take classes that will help you in future in your career. I also took a snapshot of the calendar. Our full session will start on August 17th. So for those of you who will not be here physically, you should be able to join us online. You will get the same class content that anyone else gets ever, taught by the same faculty member that you heard about in various concentration areas. The full term session, the last day for registration is August 13th. And the last day of classes, this is going to change, even though the calendar says that it is December 3rd. Because of the unusual COVID situation, what we are trying to do is still maintain the same number of classes, but slightly compress. So this may end up being sometimes in end of November, around 25th or 26th of November. If you are ready to register, you should be able to do it hopefully right after this presentation. If you need any assistance, please contact us at ECE Grad Program. And if you decide to defer your admission for some reason to spring 2021 or fall 2021, you have to do it online on the online portal. If you need help in terms of getting instructions, please send an email to ECE Grant Program at utdallas.edu and we will be able to help you. We prefer that all university business should be conducted using UTD email account. Now, for the international students, we have implemented what we call as F1 virtual start. We understand that most of the embassies are closed, airlines are not flying, you may not be able to come physically to UTD campus. So we have implemented what is called as a virtual F1. You can apply to obtain your I-20 through the UT Dallas I-20 portal. The physical address is also listed on this slide. And you can notify university about your intention to take your studies virtually. By that, what it means is that you will want to come to UTD when things open up, but you will go ahead and get started by taking online classes so that you don't waste any time and you will be able to join in a timely manner. So F1 Virtual Start will basically give you all the tools that you need to get started with UTD. And as soon as you obtain your visa, you should be able to come in and join us physically on campus. If you already have your I-20 and you will not be joining the campus in fall 2020, I understand some of the embassies are starting to open and they are processing visa applications. But if you will not be able to join fall 2020, then you will need to update your I-20 depending on when you will come, and the program start date will have to change. So again, please go to the iComet portal and make sure that you inform and get a renewed or the new I-20 that gives you the new program start date. We have graduate advisors who are also on the call, Dr. Marco Taka, Dr. Randy Lehman, Dr. Matthew Hines, and Diana Kogan. They will be available to help you decide the courses that you should be taking starting from fall 2020. And later I will share their email addresses as well as their meeting rooms that will be available online. So in the first semester, we will be sending out an acknowledgement of policies form, an online link. Please go ahead and acknowledge the policies. Plan your degree with your advisor. So after today's presentation, you will be able to talk to your advisor both through WebEx as well as other portals. I will share those details. And once you finish that, you should be able to register. In the subsequent semesters, you will be required to submit your degree plan by the end of first semester or sometimes in January 2021. We always recommend very early registration for all our students, and students should make sure that they register for classes to avoid any last-minute disappointments. When your degree plan, it is possible that you listen to all the 5 faculty members in concentration areas and computer engineering and telecommunication engineering, and you find a course that, or you find a topic that simply is not there. In that case, you can approach a faculty member and ask him or her that you want an individual instruction. An individual instruction is an agreement between you and a professor to take a very, very specific focus topic. You are allowed to take one individual instruction, which is 3 semester credit hours, between now and end of your degree. And in addition, all our core courses are core as well as elective courses. They are labeled as at level of 6,000 or higher. So UTD uses numeric designation. The courses that are below 6,000 are not considered as graduate level courses. But some of you probably got a prerequisite which is at 5,000 level. So you can take one 5,000 level and count it towards your degree. We will still allow that. If you are a PhD student, then your requirement is that you should complete 75 semester credit hours beyond your bachelor's degree. So if you are coming with an earned master's degree, you will get a credit of 30 graduate courses. And then after that, you have to do some more courses and the research hours so that you get to the minimum of 75 before you can get a PhD degree. That said, I will also tell you that in practical cases, most students will go much beyond 75 semester credit hours. A PhD student must pass a two-part qualifying examination. The part one tests the fundamental background knowledge, and it is based on courses that you take here at UTD. And part two tests your research capability by studying some research papers and making a presentation in front of a committee. Students with MSEE must pass this qualifier examination in 3 long semesters. So if you're coming in fall 2020, then you really have till the end of fall 2021 to pass this qualifier examination. Those students who are coming after bachelor's degree will have 4 long semesters to complete this examination. And a student gets maximum of 2 attempts to pass the qualifier examination. So PhD students need research advisor consent to register for the research courses, which means if you have a research advisor who has already agreed to work with you, they will be the ones who will sign for your courses. If you do not have one, then the graduate program head is your advisor till you find an advisor. And generally it is expected because you have a qualifier requirement, you will find an advisor as soon as you arrive within 1 semester of your arrival. The PhD students also must form a PhD dissertation committee, but that typically will happen after your qualifier examination. And then they also must pass a doctoral proposal examination. So in sequence, if you look at it, after you arrive, you have to do a qualifier examination, form the committee, and then pass the doctoral proposal examination. Then you complete your dissertation in the form of an original research and defend it publicly. As I said earlier, it is required to maintain a grade point average of 3.0 in all your courses. If your GPA falls below 3.0, you will be placed on academic probation. And once you're placed on academic probation, you get at most 2 semesters to bring your GPA above 3.0. And if that does not happen, that will result in immediate dismissal from university. A student, if he or she does not do well in a course, then you can repeat that course, and you are allowed to repeat no more than 3 courses, and a course cannot be repeated more than once. If you are transferring from another school, then you are allowed to transfer 25% of your graduate course work. So the way it works is UTD degree requires 33 semester credit hours. The 25% of that will be 8.25 credits. So essentially you can transfer 6 credits, which will be 2 whole courses from a different school. And you must finish the necessary paperwork at the end of first semester after finishing 9 credit hours at UTD if you're intending to transfer courses from another school. It is possible that some of you may feel that you were given prerequisites for knowledge that you already have, and we will allow you to request for the waiver. And in that case, you have to fill a waiver form and prove that the prerequisite was taken in the last 4 semesters of your undergraduate degree. And we should be able to do this. In order to do it for the fall 2020, the deadline is August 30th, 2020. With that, I will quickly give the the online stage. Basu, Dr. Basu, you have a couple of minutes to quickly mention about your research He is the newest faculty member in our department. Dr. Basu.
Yeah, thanks, Dr. Bhatia. Thanks for the introduction. Hello, everyone. Can you guys hear me?
Yes.
Okay, thank you. So, hi, everyone. Welcome to UTD. I have been here for less than a year. Actually, it will be 1 year in 15 days. I joined last August. And to tell you briefly about myself, although Dr. Bhatia mentioned, I did my PhD from the University of Florida. And then I had over 5.5 years of industry experience in various companies like Intel, IBM, and Synopsys. After that, I decided to move back to academia. I was at NYU for a couple of years, and then I moved back to UT Dallas. So my lab is called the Trustworthy and Intelligent Embedded Systems Lab. So, you know, everything is now embedded. Everything we talk about is in embedded systems, whether it's in your cell phone, it's in your computer, everywhere you are having smart, intelligent embedded systems in the Internet of Things, right? You have like, even when I was a graduate student and an undergraduate student, we couldn't imagine this concept of drones going around. Now we have drones that are being used for multiple purposes, whether for shooting videos or for the Air Force for surveillance purpose. We are having self-driving cars coming up. So our research in our group focuses on how to make these embedded systems more secure, that is trustworthy, and more intelligent. Like, for example, there are 4 aspects in our research that we do in our lab. First is hardware-based antivirus, as you can see in the picture here. So almost all of you have used some form of commercial antivirus software in your life sometime, if you have used a Windows machine probably. But these antivirus software solutions are not robust against complex malwares that are being deployed in IoT devices these days. So we developed these hardware-based antivirus solutions where hardware is used as the root of trust. The circuit that you use for designing a chip will act as an antivirus solution, not the software acting on top of that. Then we work on hardware security, as Dr. Sheffer mentioned, where we're trying to make sure that the chips we manufacture are secure. Like most of the companies these days, like for example, Apple or Qualcomm are fabless, right? They outsource the fabrication to a third-party fab. Now, how do you ensure that these third-party fabs do not introduce some abnormalities in the design? By abnormalities, let me give an example. Suppose a third-party fab just introduces something like a counter which counts for 1 year and then stops the chip from working. You buy an iPhone, and after 1 year, you see your iPhone stops working. You will blame Apple, but Apple is not the one to blame. It's the fab that is to be blamed. So how do you ensure these type of mishaps don't happen? That's what we work on in hardware security. The third aspect that we work on is functional safety. As you know, we have been working on automotive self-driving cars all the way, and we collaborate with Ford Motors in this research. So how do we ensure that these automotive cars, they do not have any accidents when there are faults in the hardware? So if there's a fault in your cell phone hardware, if there's a fault in your computer hardware, the worst thing that can happen is you will throw them out, you will lose some money. But imagine if you're driving on a US highway at 70 miles an hour, or if you translate that to kilometers, it's 112 kilometers an hour, and there's a mishap on your chip and your brake doesn't perform well. What happens? You might reach a fatal accident. How do you ensure that these things don't happen? That's what we work on, functional safety. The last aspect that my lab works on is neuromorphic computing. We all know that machine learning has been growing exponentially these days. Everyone is interested in machine learning and deep learning. But machine learning and deep learning software have their limitations on performance if you apply them to a general processor CPU or a GPU. What we try to devise is we are designing custom hardware accelerators for machine learning systems. One example is Google's Tensor Processing Unit, which Google came out with in 2017, which is a custom neural network accelerator. We are trying to do that, but in a much faster way, using novel devices and technologies which can run at the speed of the brain and as well as consume as little power as the brain. So just to give you an analogy, many of you might have seen the Deep Go program by Google defeated the world's best Go player a few years back. But do you know how much power the Deep Go computer requires? It requires more than 190 CPUs and 400 GPUs to perform. That's an enormous amount of power that's necessary. Your human brain doesn't require so much power. So how can we translate these machine learning tasks to a human brain type of way where we consume less power and we have better performance. So these are the 4 aspects of our lab that we work on. Please feel free to email me or set up an appointment if you want to talk with me about my research. If you want to do an MS thesis or an independent study with me, I'll be more than happy to do so. If everything was open, I would have asked you to drop by my office anytime. But now, since most of us are working remotely, it would be better if you send me an email. I would be really happy to talk with you, explore various research opportunities, and find out a suitable program for you. Okay, and of course, I'll be offering a hardware security course in the spring. So if you're interested, it's a graduate level course. It will not have any exams or anything. It's mostly project oriented and research paper oriented. If you want to attend that course, please feel free to register in spring. Please let me know if you have any questions. My email ID is in the slide. Thank you.
Thank you, Dr. Basu. I know we are running a little bit over time. We should have finished by now. We have about another maybe 4 or 5 slides that will bring us to the end. I quickly also want to give you instructions on how to start getting into the advising as well as registration session. But before that, I will bring in Satvik Datta. He's a PhD student in our department. He has a background very similar to what I will call as mine. A long time ago, I started out as a MS student, actually in UTD, and suddenly one day I switched over to the PhD program. So Satvik came in 2018 as a MS EE student, and then he joined in 2019 the Center for Research in Speech Systems, and now he is pursuing his PhD in electrical engineering. So Satvik, I will take you to the next slide and you can quickly talk about your experience and give some tips to the students that are online. Go ahead, please.
Thank you, Dr. Bhatia. Am I audible?
Yes, go ahead.
Yeah. So congratulations and welcome to UTD, everyone. So I have some very small tips for you guys. So please choose proper courses, talk to your academic advisor, research advisor, or the PI of your lab. Please ask questions, engage in interactions and discussions in your courses. Feel free to meet your professors in their office hours during e-learning. And since I have a master's, a course-based master's to a master's thesis and PhD, that is how I move through the program. As Dr. Ketan Nawaz mentioned, you should go to the UTD ECE website, scroll through the faculty list based on the research interest, go to their websites. And the best way to engage with professors is to take their course and read their papers. There will be other details. And also if you pursue research opportunities like research, the opportunities to apply for fellowships and scholarships increase, both at the department, school level and Office of Grad Education. But you need to be really interested in research. You need a very good GPA, more than 3.5, the more the better. Strong letters of recommendation, publications, which you will do, or if you have, that's better, and a strong research statement. Dr. Bhatia, the next slide. Very briefly about my research. So I work with the Center for Robust Speech Systems, and my project is in collaboration with the Kalia Center for Communication Disorders. It is a medical center for children. So I'm currently working on developing a screening tool for children who might have speech sound disorders, kind of 3 to 6 years old. And our goal is to develop a system that will take speech samples from children. So you can see on the left-hand side, that's an iOS app that we have, and we'll recommend the caregiver or the parent that they should visit a speech language pathologist or a doctor in speech language therapy. And my motivation throughout has been my advisor, my professors, my peers, the research and the research subject that I work on. ECE is a great place. You can do you will get a lot of research opportunities. I took courses from biomedical engineering and also from the CS department. You have lots of flexibility. Please talk to your professors. Thank you so much. Dr. Bhatia, the next slide. And this is in very short. I also represent the UT Dallas Graduate Student Assembly. So I have been elected as the Johnson School representative for 2021. Any graduate student, master's, PhD, TA, RA can reach out to us. It can be academics, research, mental health, campus school or departmental life. It is an independent student body, and we work in collaboration with various offices across the UTD administration, and the handles are provided at the bottom of the screen. Thank you so much. Stay safe and take care. Any questions, that drop me an email. It is on the slide. Thank you so much.
Thank you, Satwik. That was very helpful. I also quickly want to mention that most of you have the UT Dallas address, but if you have any problems related to your computer account, you can always send an email to assist@utdallas.edu. And finally, as I mentioned earlier, we have a very, very large industrial placement program for internships and co-op. Jerry Alexander, Mr. Jerry Alexander is Assistant Dean. And if possible, please do reach out to him on LinkedIn. He is called as the internship guy, and he has more connections that you can imagine. So Mr. Jerry Alexander at jerryalexander@utdallas.edu is very helpful in making sure that your resumes are correctly placed in right companies, and you will get good internship opportunities. I do want to mention about academic dishonesty and plagiarism, that we take these issues very, very seriously. I have provided some links for various issues. In your leisure time, please go through these pieces of information. Plagiarism is highly discouraged, and there are discipline committees. And I have seen students for some very, very small issues, they get into the problems. So if you have any concerns or issues with your academic progress, please always feel free to reach to faculty or your advisors. Everyone is very, very helpful. Do not take those undesired steps. TAs and RAs are required to work for at least 20 hours a week. There is heavy competition for limited TA openings. The research assistants are awarded by faculty depending on their own research funding. You need to be a full-time student and register for 9 semester credit hours and at least 6 hours in summer. TAs and RAs should submit their monthly timesheets in a timely manner, and TA also need to hold their pre-announced office hours every semester. If you go to our website, ECE.utdallas.edu, and look at the graduate program, I want you to notice that there is a link called as Forms and Links, and that has pretty much every piece of information that you will need as you progress from your admission to when you're in the department, once you graduate, once you get a job and you become an alum. All the informations that you will need for support from the ECE department are listed there. In addition, the Office of Graduate Studies website is also listed, and that is where you will get information with respect to the requirements for your thesis, your dissertation, the formatting, the submission guidelines, deadlines for graduation applications, and form submissions. Finally, I just have maybe 3 more slides. In the packet that was sent to you, we also sent the list of courses that are available for the fall 2020 semester. And I'm just showing you a quick snapshot so that you understand how the courses are numbered. Say, for example, you are interested in taking a course which is listed for fall 2020. If you are interested in taking, say, VLSI design, then if you will look at this column here, then in the row that I have highlighted, EECT is the course prefix for this class. Then we have a course number, which is 6325. As I said earlier, a course that is labeled 6000 and higher is a graduate level course. Section is 002, that is which section you will be listing. And then there is an internal course reference number that the university uses. So 83723 is the course reference number. Then we have the name of the course, which will be taught by Professor Carl Seichen. It is offered on Monday and Wednesday from 1600 hours to 17:15 or 4 p.m. to 5:15 p.m. It is an online offering. So that is how a course is available to you. There are multiple courses, and we are also placing courses in right time windows for those international students who may want to take courses in convenient time slots. Once you pick up a course that you're interested in taking, you will find that the registration form, which is also included in the packet that was sent to you, you will fill that form. So the way you fill this form is you first write your UTD ID number that was assigned to you once you were admitted. Then you put your name in here. And then what you do is you decide that I want to take EECT 6325. So you put the 5-digit CRN number, the course prefix, course number, section number, and all our courses are generally for 3 credit hours. Once you finish this, you will do this for 2 more courses or as many courses as you want to take. A graduate student is openly allowed to take no more than 9 credit hours in a given semester. So if you are taking courses online, especially for those international students who may be coming from outside the United States, you are not under the rules of F1. So you have the flexibility of taking courses anywhere from 1 to 3 number of courses. If you are an international student and you are in the United States, you should take 3 courses, which is 9 credit hours. If you're a domestic student, I know we have a lot of students who are coming in from our fast track program. Again, this is how you fill the registration form. I know you must be familiar with because you may have filled this in UTD earlier also. But once this form is filled, you should have this form signed by one of the advisors. So in order to facilitate the advising, what we have done is our advisors, Dr. Randall Lehman, Matthew Hines, Marco Taka, and Diana Kogan are available. I have listed their WebEx meeting rooms. So the way it works is you go click this link during the time windows that we have shown here. And these are all times that are listed in local Dallas time. So the Dallas time means that if you're looking at right now, if you're coming from international locations, it is 10:14 in the morning. So I know, for example, if you are in India, then it should be 8:45 in the evening. In China, you move another hour and a half ahead. These are the times that are available for Dr. Randy Lehman, and this is his room. So you click on this link, you will get to the room lobby, and he will let you in, and he will have a one-to-one conversation with you. You can turn on the video, you can turn on the audio, ask him questions. What are the appropriate courses that you should take? So if you are one of the 5 EE concentration areas, please feel free to visit Dr. Randy Lehman, Matthew Hines, or Dr. Marco Taka. If you are a telecommunications engineering student, please visit Dr. Marco Taka. If you're a computer engineering student, then you can visit Dr. Diana Kogan. I will be sending out her WebEx room information in an email. But in addition, for computer engineering students, you can always come and visit me. So for the next 1 full week, I will have my WebEx meeting room that will be open from July 20th through 24th. So I will be available today, right after this talk, and you can just come in, knock on the door during the meeting hours. This is my meeting room location. Or if you want an appointment, you can send an email to dinesh@utdallas.edu. For all ECE graduate program related matters, please send an email to ECE grad program. So your next steps really are that you should look at the packet, look at the courses that you will be interested in, think what areas you will be interested in registering, and then set up an appointment with one of the advisors or me. Come talk to us. We will help you fill the registration forms. and then those forms will be sent to the ECE graduate program. The staff will register you and send an acknowledgement that you are registered. If you are already familiar with the UT Dallas system, and if you go online and you notice that there are no holds on your registration, you should be able to register online by yourself. So with that, I welcome you to UTD, and I hope to see you all in person in very near future. Till then, please stay safe. Please maintain social distance. And for any questions, feel free to reach out to me, anyone in the department, and we will be happy to help you in any and every possible way. Thank you for being here today. I welcome you. And if you have any questions, I understand you have typed some questions in the chat box. We will be collecting those questions and sending in the replies back to you. And in addition, for those students who will put in questions, we plan to arrange another webinar, which will be specifically for answering your questions, most likely sometimes next week. With that, good luck to you. Good luck to you in your academic endeavors. And the faculty is looking forward to seeing you physically on campus. Hopefully this COVID will be behind us. Treatment will be found, vaccination will be there, and we will welcome you in this happy environment sometimes in very near future. Thank you and have a very, very good day today.
Thank you, Dinesh. Thanks everybody for coming.
Thanks, everyone. Wish everybody the best. And hopefully we see our students soon in our virtual classes as well as on campus.
Yes, very much.
So this session was recorded and we will be placing the recording on our website.